Hello and welcome to my video on Prim's algorithm. Now, Prim's algorithm is an algorithm that will find the minimum connector of a graph. Now, a minimum connector is the shortest weight value of a way to connect all the nodes on a graph without creating any cycles. A cycle is when you have nodes and you can create a loop between them like this, so you would go round and round. That would be a cycle. There are none of those in Prim's algorithm. So we want a minimum connector, so a way to join up all the nodes without any cycles and doing that in the smallest weight possible. And this is how you do Prim's algorithm. This might look like it's some massive scary diagram, but it's actually really easy to follow. And if you just print screen this page as it is now and memorize this process, you'll be able to do Prim's questions no problem. So the first thing you do is select a node to start at. It doesn't make a difference. Normally it'll give you one to start at in the question. If not, just pick like the first alphabetically or something. And from that node, you will pick the arc of the lowest weight that is attached to your selection. And the minute we've just got one node selected, so it will be the lowest weight arc coming out of that node. You look to see if it creates a cycle. If it did, you would delete it from the diagram and go back to picking one. If it doesn't, you will select both that arc and the node it leads into. You'd then look to see if all your nodes were selected. If they are, you can stop. You've got a minimum connector. If they're not, you go back to picking a new arc. But this is all a bit hard to understand just looking at it, so I'm going to go through a worked example. So here we have a graph with some nodes that are letters and some arcs that have weights on them. We're going to use Prim's algorithm to find the minimum connector. So we're going to select a node to start. We're going to select A. So I'm just going to circle that to show that it's selected. Next, we're going to pick the arc of the lowest weight that is attached to the selection. Well, this is my selection, so our options are 5 and 7. And 5 is the lowest one. So we're going to have a look. Does it create a cycle? It would go down here. That's not a cycle, so that's alright. It doesn't create a cycle, so we're going to select both the arc and the node that it leads into. So we're now going to select this arc and this node. So now we need to check, are all the nodes selected? Well, no, they're not. We only have A and B. There's still all these to select. So they're not selected. We'll go back. We're back here. We're going to pick an arc of the lowest weight that is attached to the selection. So this time we have both A and B selected. So our options are 7, 3, 15, and 6. Well, in this case, 3 is our lowest one. So we would look at that. Will it create a cycle? It won't. So we're going to select that and the node it leads into. We'll have a check. We haven't got all the nodes selected yet, so we're not ready to finish. We'll go back to looking at our selection. We have the options 7, 8, 7, 15, and 6. 6 is the lowest of those, so we check this. Would that create a cycle? No, it wouldn't. That's absolutely fine. So we'll select both this arc and the node it goes into. Again, we check, have we got all the nodes yet? No, we don't. So we go back to our selection. What do we have? 11, 8, 15, 7, 8, and 7. Now here we have two arcs that are both the lowest weight, so it doesn't matter which you pick. If that happens, you can pick either. So let's pick this 7. We'll look, would it create a cycle? We'll find out, yes it does. If we selected this, we would have A to B, B to C, and C to A, and that's a loop that you could keep going round, so it's a cycle. We don't want that. So if we check our instructions, if it is a cycle, we delete it and go back to selecting. So I'll change to a red, and let's just delete that arc from our diagram. Go back to our green now. I've missed my button, there we go. So now we go back to our selection. We'll have a look at the nodes, 11, 8, 15, 7 and 8. 7's the lowest. We'll check, would it create a cycle? It wouldn't. So we select both the arc and the node. Have we got all the nodes yet? No, we do not. So we go back to our selection. We have 15, 8, 11, 9, 5 and 8. The lowest is 5. Would it create a cycle? No, it wouldn't. So we select that and the node. Now, is that all the nodes selected? It's not. We go back, look at the selection again. 8, 15, 8, 9 and 11. So the lowest is one of the 8s. It doesn't matter which. We'll pick this one. Would it create a cycle? Yes, it would. CDE would become a cycle. So that means that we need to delete this. Go back to our selection. The lowest is 8 again. Would this create a cycle? Yes, it would. FECBF would be a cycle. This one uses 4 nodes, but it's still a loop. So we don't want that. So we delete that arc. So we go back to our selection. 15, 9 or 11. 9 would be the lowest there. We'll have a look. Does that create a cycle? It does not. So we select that and the node. We check, are all the nodes connected? Yes, they are, which means we're almost done. All that's left is to draw out what we found. So obviously all the nodes are still going to be there, because the whole point of this algorithm is just selecting every node before you stop. But we're just going to draw on the arcs that we had selected. So we have this one of 5, this one of 3, a 6 here, a 7 here, and then a 5 and a 9. And this is the minimum connector of this graph. To get the total weight, you just add up these values that we'd selected. And that's really as easy and as difficult as prims will get. There's not really much more they can ask you on it. So it's just remembering this process, just sitting down and learning it. You select a node to start, you pick the arc of the lowest weight that's from your selection, check it doesn't create a cycle. If it does, get rid of it and go back and pick another. If not, you select both the arc and the node, then you'll check, are all the nodes selected yet? If they're not, you'll go back, pick another arc, carry on the process until all the nodes are selected, and you can stop there because you have found your minimum connector. So I hope this has been remotely useful. I'm probably going to do one of these for all the algorithms in D1, because for me the exam is in a week. So if you leave any comments with any problems, I'll try and explain anything that I haven't been totally clear on. Thank you for watching, and I'll see you later, guys.